Hello, this lecture is on section 5.2 from the Larson book, Normal Distribution, Finding Probabilities. Now I mentioned up here that you can use a basic scientific calculator and the probability table, but the way I've been presenting the lectures, it's more technology based now than it used to be. So looking at the calculator or Excel, which I would recommend. Now we've talked a little bit about these, and you've seen the normal CDF, so you're going to see it again. So I'm just kind of showing the idea of the inequalities. I guess when I first created this video, I had not used the normal CDF before in section 5.1, but we've already used it now, so we ought to be kind of familiar with some of this down here. And then there you go, the negative 1e, 1e, the 99. So I'm not going to read through this, but it's probably a good idea if you do. But you've already kind of seen some of this done. All right. Except for this last part. Now, here, we've been dealing with random variable z, which is your standard normal distribution, which has mean 0 and standard deviation 1. In this section, we're going to deal with just a variety of normal distributions with different means and distributions, and we're going to see how to enter that. All right. Okay. Now, what you're going to see, like I said, the normal CDF now is, we had that 0, 1 was in there as the default, but we're going to enter whatever the mean and standard deviation is given in the problem. So what we're going to do is just do some examples here of applications where the data, we assume it's normally distributed. With some sort of mean and standard deviation. And we're going to calculate probabilities of certain events happening based on that information. So I've kind of got the old school way to do it there and there too, but you don't have to worry about that. You can just decide how you want to handle it. So we got a normal distribution that has a mean of 200 and a standard deviation of 40. Okay. And the first question says, find the probability that a bulb selected at random lasts more than 250 hours. Okay. So using you would convert this, if you're kind of doing it the chart way, you would convert it to Z, like we saw in that last section, how to convert a value to a Z if we needed to. So you take 250 minus 400, and you get 1.25, and if you're using the chart, you wouldn't want to flip it over and change the sign and make it negative. Look it up, get 0.1056. Okay, so that's how you would do it that way. Well, let's focus on our calculator and Excel way here. The normal CDF greater than, see, the normal CDF and the calculator, you don't have to convert it to this Z. That's the beauty of it. I mean, you can convert it to the Z and then do it, but you don't need to. As long as you put the mean and standard deviation in there, it takes care of it for you. So I'll put, X is greater than 250. So I put the 1e to the 99 in there to represent positive infinity. The mean is 200. The standard deviation is 40. And there we have it, and we have 0.1056. I just rewrote this as a percentage. We may see problems. You might see one on a test where, the answers are in percent forms, but that's certainly not difficult to do. All you're doing is multiplying your decimal answer times 100. Okay. And in now see, okay, in Excel, we're using a different function now. It's called norm dist. Not norm S-dist. Norm S-dist, S was for standard normal distribution, meaning your mean is 0 and your standard deviation is 1. Now norm dist needs you to tell it what the mean and standard deviation are. And that's what we want. We want to tell it what it is. So we put our X value in, 250. We tell it the mean is 200 and standard deviation is 40, and it's still going to be true. But we do 1 minus. I didn't show the answer there, but I would not have posted this in the notes if it did not produce that answer, but maybe I should do it anyway. So let's come over here, and I could bring stuff up. I'll copy. Yeah, I could maybe copy these, and I have to change them to norm dist. Okay, so let's put paste right there. Okay. So I want this 1 minus 1, the last one here. Except now I'm going to change the command to norm dist. And it's telling me across the top there it wants the x value, the mean, the standard deviation, and cumulative, meaning true. So the x is 250. Means 200. 40 is the standard deviation, and there's true. So now I'll just copy this back into the notes and save that. Yeah, I guess when I did these the first time, I would have looked to see what the answer was, but I didn't bother copying the answer. But now I think I will. Yeah, I would not have just left an incorrect thing there. So there it is. Excellent. Now the next one says find the probability that the bulb will last between 180 and 210 hours. All right, fair enough. All right, I'll skip the old school method of it there. Calculator, you do normal CDF, you put 180 as your lower, 210 as your upper, the mean 200, standard deviation 40, hit paste, there are all the values, and that has 2902, which is what I got right here. And norm dist, anytime it's between two numbers, yeah, that doesn't matter whether it's norm s dist or norm dist. Meaning, if you got to do 1 minus, you got to do 1 minus either way. And same thing here, you have to subtract whenever it's between two numbers. So I think I'll put that one back in there just so we can, hopefully I'll have to shrink it in probably a little bit just to fit the answer in there. That's okay. So it's 210 at 180 and 210. I actually should have copied. Well, that's okay. I'll get rid of these parentheses and the 1 minus, which I don't need. Norm dist. So I need 210. Means 200. Standard deviation 40. Let's come over here. I got to change the S. Get rid of the S. And it'll be 180. And same mean and standard deviation. Got to get rid of the right parentheses there. So if not, that will be a syntax error. I either had to leave them both or get rid of both. Ooh, let me stretch this out so we can see it. All right, whatever I did, I didn't mean to click that. What in the world happened here? All right, I paused whatever button I hit to mess all that up. I paused it to fix it. It's going to be hard to shrink in there and keep the answer, but we can try. Okay, well, that's going to fit in there all right. Wonderful. I'll go ahead and save the notes. So I'll be reposting them anyway. All right, Dodge Durango auto transmission gets an average of 18 miles per gallon in the city with a standard deviation of 1.5 miles per gallon. What is the probability that a Durango selected at random gets more than 20 miles per gallon? Assume the mileage is normally distributed. Okay, so we'll skip the converting it to Z and using the chart, and I'll jump right down here. And like I said, you'll see more of these in the calculator, especially as we get to the homework for sure, but I'm hoping you can see what's going on here. So greater than means you start at 20 and you finish with 1e to the 99 for positive infinity. You put in 18. You put in 1.5 for your standard deviation, and there you have it. And I'll just copy this over so I don't mess it up here. So I'll keep toggling back and forth. Let's put it over there somewhere. Yes, I'm just going to go right to this norm dist at the bottom and just type that right in there. $18, 1.5, and true. And there we go. 0.092 looks good. So let's copy that, 0912. Let's copy that to the notes. Oh, and the wrong notes. It's the last section, so here's our section. And there we have it. So let's look at this example. So I may not re-enter some of these. I'll just kind of explain them real quick since they're already here. And like I said, we'll be doing some fresh problems. There's one right down here we can do. So let's just kind of walk through these, and I won't say, I'm not going to, yeah, even though the norm dists all need to be redone, I may type them in there later myself before I publish the notes again. Let's just save you some time here. Like I said, you're going to see this done in the homework, so live action for both ways. All right, means 100, standard deviations 12. We select a water bill at random. Find the probability that the bill is less than 80. So there's kind of the old-fashioned way, which I, kind of want to leave in the notes there. I'm not ready to totally get rid of that idea yet, even though we're not required to have to use that method. So less than means on normal CDF, you start with the negative 1e to the 99 as being negative infinity. You put 80, you put 100 for the mean, you put 12 for the standard deviation. And you get 0.0478. And norm.dist, 180 is the x value. Because it's less than, that means you don't have to do any kind of 1 minus or anything. 100 is the mean, 12 standard deviation, true, and that's going to give us this answer. And the reason why this is off a little bit, I don't know if I've mentioned this in the last section or not, I'm not sure if I said it, but anyway, it's because, and it won't, on a test, it might actually have this pink answer, but if you get this answer, just pick that one that's very close. There won't be a bunch of answers that are that close together. But I'll tell you at least what the reason is some of these test banks I use and stuff, they have this if it was done being the old method with the chart. And because you round the z to 2 decimal places, it's not as precise as the technology, because the technology can calculate that area with more decimals in there for the z. So that's what makes the answer a little bit different. So technically the calculators and Excel are more precise because they're using more decimals for the z. Now, if your z calculates to something where rounding wasn't necessary, then they're pretty much going to match up. Let's say if it was exactly negative 1.5, perfect. And yeah, then they're going to match because no rounding was involved. So basically the difference between this one and the technology is if this is negative 1.67, that meant really it was going to be negative 1.666666 or whatever, and it can use a bunch of those sixes over here. Anyway, between 95 and 128, excuse me, 95 and 128. Normal CDF, when you're between two values, you lower than upper. There's no E of the 99s. 100 for the mean, 12 for the standard deviation. Now for the norm dist, and same thing for norm S dist, but that's not relevant here. But you have to subtract them. It's not like, it's not like the the calculator where you don't have to do that. So you just put 128 in there, 100 for the mean, 12 then true, then the lower number, 95, 100, then 12 and true. And that's going to match the same answer. More than 138. Now the calculator, so more than means you start with your number and you go to the 1e to the 99, 100, and then 12. Now this is just scientific notation. This e to the negative 4 basically means times 10 to the negative 4. It basically means you move the decimal back 4 places. Move it 4, and it's going to leave 3 zeros in front of it. So the number is actually 0.00077, but the 77 then would round to 8. I think I'll put that one in the calculator right now, in Excel right now. 138. $100. Okay, 12. Yeah, you see it's 0077. Of course, you can format this to round to 4 decimal places if you want to. You can make it do it, and you don't have to do it. Okay, I'll shrink this in a bit. All right, I don't know where that just went. Oh, there it is. All right, just kind of shove that in a little bit. Cut this one out. There we go. Now here's one more than 85, so basically the same kind of problem. So you see the normal CDF just changes this from 138 is the first number, now it becomes 85. And then the norm dist just changes then the first number from, I'll type that one in again, because it'd be real easy to do here since it's already set up with the mean and standard deviations already set up. So all I got to do is just change this 138 to 85. Super quick and easy. Um, all right. Oh, okay. Here I'm explaining okay. This is explaining what I've already said about the chart value being on test sometimes and not matching up because of the rounding. So, okay, so that's all that's talking about. So, meaning if you don't get a perfect match, that's okay. You know, just go with the closest answer on a test. Now, of course, in the homework, that's not going to matter at all because it's going to accept the technology answers. Let's take a look at this one. Average person time a person spends on social media per day is 49 minutes. Assume the standard deviation is 16 minutes and the times are normally distributed. So that's just there to verify that we can use the normal distribution. What is the probability that we will a person selected at random will spend more than 60 minutes on social media in a given day? Greater than, so you can do it either way. Calculator, start with 60, go to 1e to the 99 for positive infinity, 49 and 16, 2458 and 2459, and we can check the norm dist here. I'll just cut that out and paste it because I'll just paste the new one with the answer. All right, just makes it easier this way so I can see all the numbers, not have to memorize them. 49. There we have it. Wonderful. Let's see, suppose SAT math scores are normally distributed with a mean of 518 and a standard deviation of 115. What percent or probability, now, okay, what percent of the scores are less than 500, which is also saying the same thing. It means the same exact thing as the percent would just be given, as a percent, but it would be the probability of any one person having a score less than 500. So those are synonymous. And so less than in the normal CDF, you do this as negative 1e 99, 500, 518, and we can't see it, but then the 115 standard deviation would be at the end. And because it's less than, it's just regular norm dist, no 1 minus or anything. 500 is our x value. 518 is the mean, 115 standard deviation, and true. And like I said, I'll probably repost this with verifying it matches that answer, but we can go ahead and go on to part B for now. Okay. Let's see. All right, so what does part B say here? I'm going to read that while I'm doing this up here. Don't like the font. It's too big. If 1,500 scores are selected at random, about how many scores would we expect to be less than 500? Now, way back in the first unit there, we had a problem like this with a pie chart. And what we took the example where if you had a total amount of people and whatever percent of the pie is, you multiply it by the percentage, and that would tell you how many people belong to that particular thing. Okay, same idea here. There's not pie charts or anything like that. Is you just take the percentage, the answer that we get, and you multiply it by the total number of people. Now I put the squiggly equals here. It's just multiplication in the calculator. 4, 3, 7, 8, 1500. The answer has to be a whole number because it's a number of scores. So you can't. So and you can just use normal rounding on this. I don't know what that number is. We can check real quick. But it's not any special thing like class width where you have to round up or anything like that. You can just use normal rounding, round to the nearest integer. I guess I just didn't put this in there, but I guess I can add it in there now that I'm doing it. But it's just straight up multiplication. So yeah, I guess I can just snip this in here. All right. I didn't get the snipping tool, did I? That's what I meant to get. Oh, there we go. Yeah, so I'll just snip this out, even though there was nothing, special being done in the calculator here, but it doesn't hurt to put it there. Like I say, normal rounding, so we got 657. Okay. Well, we're now in the homework, and I've looked at least 2 of them I want to do. Might just put a third one in there real quick. 4, 5, and 6 are all kind of the same problems. They just kind of have 3 parts, less than, greater than, and between 2 numbers. So I figure if I show you one of these 3, that should be good enough. And the earlier problems are pretty straightforward, I think. Yeah, if you do these, you can handle all those. Number 8 is going to be like the last one I just did in the notes. Alrighty, so reading portion of a test were normally distributed with a mean of 20.7, standard deviation is 6.9. Answer the questions below. Find the probability that a selected high school student who took the reading exam has a portion of the test that is less than 19. So I'll do both of these with calculator, all these with calculator and Excel. Less than 19. So that's going to be our normal CDF, where we start with the negative 1 e to the 99. And this is 19. I'm not sure if I actually showed the entry on these with the calculator. So now you're in the notes there, but now you see them. So you see this, you see a couple of these, and that's all. So that's a difference now. It's not just 0 and 1 anymore like it was in the last section. Because there we were just trying to find, we had the z's, the values. So if you have the z value, that means these are 0 and 1. 20.7, 6.9. There we go. Put that in there, put that in there. So 4 decimals probably 4027. See how we did? Got it? Let's put it in Excel. So I kind of have all these set up, I guess what you could do too if you wanted to, and just kind of save the Excel file. If you have these set up to handle all three cases, then all you do is just go in there and type over the numbers each time. They're not in any order that we're doing these problems. The middle one is the one that's for less than in Excel. So if you wanted to change them, you could. The first two, the top one's between two numbers. The middle one, second one is less than, and then the bottom one will be for greater than. Except we haven't, okay, this needs to be changed. We haven't done this yet. This needs to be changed to norm dist. And see if I can, we'll leave the, let me just, I could go back to the problem, but I'm just going to leave this up here. Yeah. And get the values from here. Well, it won't let me move out of the way here. That's all right. I think I can fit everything in there without. Okay, come back, calculator. The X is 19. I think I know the other two. I believe it's 20.7, 6.9, comma, true. And let's make sure that was the answer. Yep, 4027. So that worked. Go back. We'll go back to that spreadsheet if you need to see that again. Part B is between 14.6 and 26.8. I already have this up, so that's good. 14.6, 26.8. And you see the same mean and standard deviations. That's what's good about doing this. It won't change them until you change them. I like 6233. Oh, then Excel. It'll be the top one. Now let me get the means and standard deviations in there. And then I'll go back and see what those numbers were again. So this will be 20.7, comma, 6.9. Okay. So I'll come over here, same thing. And 6.9. And the values were 14.6 and 26.8. So 26.8 goes first. And then 14.6 will go at the beginning of the next norm dist, which you'll see it be displayed right here in the second column. So there it is. And I believe that 6234 was our answer. Okay. Or 62, okay, well. Oh, 6233, yeah, excuse me. I thought it was a 5. I thought the 5 was over one place there. So, but either way, it probably would have been fine in accepting the answer. More than 34.9. So in the calculator, normal CDF. The lower is 34.9. The upper is 1, the EE to the 99. No, okay, I guess I didn't do that right. Second, EE, yeah, 99. As I've mentioned before, you know, when you go second comma to get that EE, but only shows one E in the calculator. I don't know why, but same numbers here. It's all part of the same problem. I like 0198. Fantastic. So that's basically saying you got to, we'll do this in Excel. It means you have about a 2% chance, just about a 2% probability, you'll pick one out at random that did better than 34.9. Obviously, so it was the elite few of the crowd that did that well. Excel, more than is going to be the bottom one. And it was 34.79. Dang it. Yeah, I can't forget the other numbers because they're right there in front of me. The mean and standard deviation are there. So 20.7 and 6.9. 0.198, rounded to 4. Got it. Oh, last question. We defined this in back in chapter 3, I believe, that a probability is the term unusual means that it's less than 0.05. So the event in part C is the only one of the three that's less than 0.05. So we would deem that to be what's called unusual. There we go. All right, so that's kind of the same problem. This one's only a one-parter. We'll do it real quick. I just thought it was interesting because there was a picture there, but I don't think it would give you any trouble. Let's do it anyway. Pregnancy. Mean 271. So basically, we're trying to find this area is the probability. So we're trying to find between 283 and 292, and there's your mean and standard deviation right there. So it's not that bad, but it won't take long to do it. So it's 283 to 292. So I can see all the numbers right there over to the right. I don't have to move anything around. So there's the upper 292, means 271, and 10. Okay, this should be promising. 0.972. And then between two values in Excel, it's always that top one right there, upper or lower. So 280, so if 292 and 283 is the lower number. I think I remember, oh, I mistyped it. I think I remember that it's 271 and 10. If that's not correct, I can fix it easily. So if that's correct, we should get a match. The only thing that should be wrong is if I'm wrong with those numbers. 0.972. All right, so I was, yeah, there it is, 271 and 10. So I'll go back to that, let you look at that for a minute then. So I got away from that real quick. So let's leave that there for a few seconds. Wonderful. And the last one I want to do is the last problem. They're putting the normal table there. We don't need this. Is exactly kind of the same, except I was using math scores as reading scores. What percent of the data less than 600? So you got less than 600, means 502, standard deviations 120. Less than means I must start with -1 e to the 99. That means the upper will be the number 600. And 502, 120. $7,929. But they want it as percent. So, and they said 2 decimals in the percent, so that makes it just 79.29%. Fantastic. Now, the part B, they're tricking you here, unlike what I did in my example. I used, the same part A and part B, but look what they're doing. Instead of using less than 600, they're using greater than 575. So what we have to do is we have to redo the probability and then just multiply that by 1,000. So they tricked us. In the notes, I didn't do it that way. I used the same probability that we got in part A. They got a little sneaky on us, but that's why I'm glad I did this problem, so now you can see it and it won't throw you off, especially if you were looking at the one in the notes. So now you'll be ready. All right, so I'll just do this. We'll start at 575 because it's greater than. We'll go to the 1e to the 99. And those numbers are the same, part of the same. Yeah, mean standard deviation aren't changing in part B. Enter. Now, I'll just multiply this by 1,000. And 27148, I'll round that down then to 271 using just normal 0.5 rounding. Yeah, round to the nearest whole number. Excellent. So I can put this in Excel real quick. And it'll be the last one here. And I'll have to go back and let me bring up my friend, the calculator here. Come on. Why won't you stay where I take you, calculator? Good grief. Why is it being so difficult here? So 575. $502 and $120. And okay, I think it was 112. I think it was 112. No, it was 120. 502, 120. I think that's. Oh yeah, that's right. Okay, there it is. So you could just reference. You could do like this real quick, or just do it in a calculator if you wanted to. You could use Excel, then switch to just any kind of. But anyway, whatever. I'm just taking that number and multiplying it by 1,000. That's all. There you go. 27148. But the key parts there is how you get the probability in Excel right there on the 5th row. Excellent. Well, that's going to conclude our video here on normal distribution finding probabilities.